Hello friends, welcome to SQL with Manoj. Today I'll be talking about improvement with existing column store indexes with SQL Server 2016. So in this video I'll not be talking about column store indexes in depth. Maybe I'll post a separate video where I'll be talking about in depth on this particular technology. So here I will just give you an overview of what is a column store, and I'll move to the enhancements. Column store indexes were introduced in SQL Server 2016 for in-memory data warehousing. Why in-memory? Because they internally uses a multi-pack engine or X velocity technique of Microsoft SQL Server to cache the data internally. Rather than using the SQL Server buffer pool, they uses a separate pool for caching the records in memory in form of column store to retrieve the data easily and process the data. So first of all, what is column store? The column store is nothing but a data in a table that is organized in form of a column rather than a row. So if you talk about a normal table in a database, there the data is organized as rows. First of all those rows are stored in a 8k page, and those 8k 8 pages are stored in an extent, and a number of extents are stored contiguously in a disk. So that is a simple table that stores the data in form of row. We can also call it a row store, but here with column store the data is not stored as a row store, rather than that it is stored as a column store. So here in this figure you can see, if you create a column store index on an existing table, that table is divided into multiple row groups. So each row group contains up to 1 million of rows. So every column in a row group is divided into multiple column segments. So if a table has, let's say, 10 million rows, then it will be divided into 10 row groups. And if the table has 10 columns, then every row group will have 10 column segments. And finally, these column segments are compressed and stored as a column store index. So what does a column store contains? It contains segments, these yellow segments. It contains a delta store and a delete bitmap, which we'll talk about later. So what is a segment? We just saw right now that each column of a row group is stored in its own segment and is compressed. What is a delta store? Delta store contains recently inserted and updated rows in small batches except bulk load, and up to a threshold of 1 million rows. So let's say if there is a table and it already has a column store index on it. So if you are doing a bulk load, that bulk of rows are not going into delta store. They are directly added to column store as segments, and they are compressed as in when they are loaded. But if it is not a bulk load, all the inserted and updated rows goes to a delta store, that is nothing but a B tree or a row store. And when the inserted rows crosses the threshold of 1 million rows, a separate process takes place that we call tuple move over. And this process, what it does is, process on reaching 1 million threshold, it closes the delta store and compresses it and stores it into the column store index. So the tuple mover process takes place after the delta store crosses 1 million rows, and it closes the delta store and compress it and store it in the column store index, right? So by all these things, how it benefits? So the first thing is it benefits by the compression. So if you see a normal table, the compression methods are row compression or a page compression. So if there is a row compression, then it compresses all the columns in that particular row. And normally in a particular row you have data with different data types, but here with column store index, every column is stored as a separate segment. So in every segment you have data of same data type. So by that you will get higher compression ratio. It does a batch processing. So when you are going to retrieve the records, it does a batch processing. Segment elimination. So each segment contains the min and max value of the particular numeric columns. So whenever you are selecting any data, like if you are doing a range selection on a particular date, so it will just check the minimum and max value of those dates on those particular segments. And if that date does not fall on those segments, it will just ignore those segments and only pull out those segments that have those particular dates. Aggregate and string push down to storage engine level. So this is a new feature that is added to SQL Server 2016. We'll talk about it. Delete buffers. So as and when the record is deleted, it does not get deleted from the column store index. There is a separate delete bitmap created, a delete buffer created, where all those unique IDs for those records are logged. So whenever you are reading the records from a column store index, all those records that are deleted are excluded from that delete bitmap, so that you won't get deleted records. And ultimately this column store index is stored in column store object pool in RAM to cache column store index instead of the SQL Server buffer pool that is for normal pages. Now we'll move to the column store enhancements. Here you can see what was in 2012, in 2014 and 2016. So you can see some of them were supported in SQL Server 2012, then some on 2014, and everything gets supported in 2016. Like the batch execution of multiple threaded queries and single thread queries. Archival compression option was added in 2014. Snapshot isolation and read committed snapshot isolation 2016. Specify column store index when creating a table. You can now inline create an column store index with 2016. Always on readable secondary support, updatable column store indexes. Then updatable non-clustered index on a heap or a B tree. Then B tree indexes on a clustered column store index, column store index on a memory optimized table. So now you can create a column store index as well on the memory optimized table also, that is the in-memory table that we saw in our previous video. Non-clustered column store index definition support using a filtered condition, right? So you can have a filtered index, non-clustered column store index by a where clause. So these are the things that I've collated here, all the new features that have been added for column store index in 2016. A table will still have a non-clustered column store index, but this will be updatable and thus the table also. So in 2012 and 2014 this non-clustered column store index was read only. Now in 2016 it is updatable also. You can create a filtered non-clustered column store index by specifying a where clause to it. A clustered column store index table can have one or more non-clustered row indexes. Previously you could have only one non-clustered index, normal index. Clustered column store index can now be unique indirectly, as you can create a primary key constraint on a heap or a table and also foreign key constraint. So till 2014 clustered column store indexes does not support primary key and foreign key, and you could not have these primary key constraints. So there was a possibility of inserting duplicate data on it. So people ended with some workarounds like creating a view on top of clustered column store index and create a metallized view or indexed view on top of this clustered column store indexes to make sure that primary key constraints are applied for that particular table. Columnar support for in-memory tables, as you can create one column store index on top of them. So now you can create column store index on in-memory tables as well. And the last new feature is aggregate and string predicate push down to storage engine level for better performance. So previously with aggregates, if you are doing an aggregate on a column store, it used to fetch all those rows from a column store index. So with aggregates, previously it used to retrieve all the rows from a column store index. Now what they are doing is they are doing aggregation at the storage level. So now with this new feature of aggregate push downs, so most of the aggregates would be done at the storage engine level and you would be getting a better performance out of it. So these are some of the new features in column store index that have been enhanced in SQL Server 2016. Hope you like this video, and if you really like this video, please like it and please let me know your comments and suggestions. And for more information you can subscribe my channel, so as and when I'll be adding new videos you'll be getting an automated feed on your email box. And thanks a lot for watching this video.